about noon on my clock. So today last week you guys were supposed to tell me about an interesting robot of yours. For some reason the homework didn't load when I had initially put it in, so I did just recently add it. So if you did not see it, don't worry about it. You can go ahead and do it just before next week. That's perfectly fine. But right now, we are going to start by sharing our projects. Now, I intentionally did not put names on these projects. So we are going to start with whoever, oh, and Dane, it looks like your name is on this one. We are going to start with Fanny. So Dane, would you like to share about Fanny with us now that we are actually starting class? If you guys could just stop in the text chat, that would be fantastic. Okay, so Dane, go right ahead.
My robot I'm going to write about is Fanny. Fanny is the biggest four-legged walking robot. It was released by Zollner Electronic AG from Germany on September 27, 2012. It is powered by a 2.0 liter diesel engine with 140 HP. It weighs a total of 24,250 pounds, or 11 ton, and is 26 feet 10 inches. I forgot to put high.
All right, fantastic. And this, I'm assuming, is a picture of Fanny here. Great job, Dane. Thank you very much. Our next robot helps people with dementia. So if this was yours, go ahead. Go ahead, Lindsay. Is this yours?
A robot that helps people who have dementia. This robot can reduce stress on patients and the caretaker. It's good for interaction with the dementia patients. It's soft and friendly, and it looks like a cute little seal. It improves patients' relaxation and motivation. It can recognize some words, and it can feel when it's being stroked. It can behave in the way the patient likes, and it will learn to respond to its new name the patient gives it. The seal will not try to do the same action if it is stroked multiple times. It can move its head and legs, make sounds. It shows the patient's preferred behavior, and it imitates the voice of a real baby harp seal.
All right, wonderful. Thank you very much, Lindsay. That is one that I have never heard of before, but it is a great idea. It sort of reminds me of the therapy dogs and cats that they have go into hospitals and nursing homes to help children and other patients become more relaxed. So great job, Lindsay. Thank you very much. Next we have Atlas. And interestingly enough, whoever did Atlas last night when I was watching the news, there was a little blurb about Atlas and how he was created by Google, and how Google is leading the way in all sorts of robotic technology research. And then when I read this, I thought, oh, whoever this is was reading my mind. All right, so if Atlas was yours, go right ahead. Oh, okay, Seth, no problem. I will go ahead and I will read this one for us. So Atlas is Seth's, and Atlas is a search and rescue robot. Meet Atlas. a very talented search and rescue robot designed for complicated terrain and climbing. Developed by Boston Dynamics, it is considered the most promising project in robotics. One amazing thing is that when Atlas is hit from the side, he balances on one leg. Also, it competed in the DARPA Robotics Challenge in 2013 to test its potential in search and rescue, climbing, running through rough terrain, and driving a rescue vehicle. He can walk, lift, carry, negotiate rough terrain, and manipulate the environment. He also has tools designed for human use. He also includes a stereo camera and a laser rangefinder. All right, fantastic. Thank you very much. And the next one is bear. If bear was yours, go right ahead.
For my robot, I chose the bear robot. This robot goes to the front lines to get wounded vets out of harm's way and keeps other soldiers from getting hurt. Also, it can travel on all types of terrain. It can carry 3 full-grown people. It can also be used for lookout missions. It sends messages back to show if the coast is clear or not. I picked the robot because my uncle and my cousin was both in the Army, and my uncle was in the Army and Navy.
Awesome. Well, bear is definitely a robot that can help Army and Navy soldiers. Great job. And the last one is Nexi. All right, Dane, let's stay on topic here. All right, whoever was Nexi, go right ahead.
The robot's name is Nexi. Nexi was made by MIT Media Lab. She can make any facial expression. Nexi is an NDS, Mobile Versus Social Robot. Mobile because she can move around. Dexterous because she can touch things and even move around. Social because she can communicate the same way humans do. Nexi moves using wheels. Even though Nexi is a robot, she can hear, talk, and move. Nexi became an internet star because she was more advanced than Kismet.
Awesome. Thank you very much, Kyle. So those of you who did this, you did an awesome job. I am very impressed. If yours is not up here, it just means that I did not see it before I went on and pulled them all off this morning. So great job. I will make sure that if it's on there, I will grade it and you can do your presentation next week. So today, we are going to talk about designing the robot. We've talked about the electronics in a robot. We've talked about the computer system and programming a robot. We've talked about the different types of robots. Now we are going to talk about how you go from start to finish to design a robot. Now, unfortunately, we don't have the means to actually build and design a robot as a class. If you have the means in your house, you certainly can go ahead and build a robot for your homework assignment. However, the rest of us are going to design a robot. So as we are going through the PowerPoint today, pay attention to what the steps are to design a robot. So let's take a look at the steps to and the thought process that goes behind designing a robot. So there are several steps to designing a robot. Sometimes scientists use each and every one of these steps. Sometimes a step or two may be skipped. The first step that happens every time is a problem is defined. Scientists determine what problem they want to solve or what task they want to complete. Then they do some research. They can research online, they can research in textbooks, and they can research by observing things. If you remember back to the beginning of the class, we watched as scientists were observing a gecko and using that as part of their research. Then they create a prototype. They may draw the prototype, or they may actually build a prototype. Building a prototype is oftentimes one of the more expensive parts of the project. Then they actually build the robot. Once the physical robot is built, whether it is a square, whether it looks like a person, whether it is my little robotic vacuum cleaner, then it needs to be programmed. Once my robot is programmed, it is tested. So for example, when we were looking at programming using Robuzzle, once it was programmed, we needed to test it and figure out what happened and if it worked correctly. Okay guys, please in the text chat or I'm going to have to turn it off. Every time you write in it, it beeps. If you have a question, certainly write in it. That is what it was there for. But let's try to stay on task. After your robot is tested, we evaluate it and we see, well, that certainly did not work out correctly and we need to change something. Or, wow, that worked out great and everything is perfect with our robot. Now, which do you think happens more often? Does everything work out perfectly, or do changes need to be made in the robot's design? Go ahead and raise your hand. Which do you think is more likely? Everything works perfectly, or changes need to be made? Go ahead, Kyle.
I think most of the time changes probably need to be made.
Awesome. Most of the time, changes do need to be made. Occasionally, things work out perfect, but definitely it is more likely that changes need to be made. So let's look at the research. Let's look at how a problem is defined. So scientists define a problem that they would like to solve by identifying the purpose of a construction. So for example, they identify, I would like to solve cutting branches off of the trees. That's their problem. They identify specific requirements. Well, my robot's going to need to reach high into the air. My robot is going to have to use some sort of a saw. My robot is going to have to identify where the pieces are going to fall. All of those things are specific requirements for my robot. Okay, you need to determine what problem you are trying to solve before you attempt to design and build the robot to solve the problem. Sometimes scientists use a notebook or a logbook to do this. Other times they keep an electronic log. The next step is to do some research. So as scientists are doing research, they need to gather information. They identify specific details of the designs, which must be satisfied. Maybe they need to figure out what type of trees they're going to target. So how tall does a specific tree get? That would be an example of some research that needs to be done. They identify possible and alternative design solutions. So for example, they may look at other robots or machines that do the same type of thing. They need to plan and design appropriate structures, which include drawings. Some of the questions that they might look at is, what is the practical function of the design? What must my robot do? So the design's practical functions can include movement. How will the robot move within its environment? If we put it in a different environment, will it still be able to move within this new space? So for example, most trees are either in grassy areas or in areas with other trees around them. So our robot needs to be able to move in those areas. Our robot probably does not need to be able to swim because it is not going to be cutting down trees in the middle of the ocean. Okay, the next question is manipulation. How will the robot move or manipulate other objects within its environment? Can this single robot move or manipulate more than one kind of object, or will it need multiple robots working together? Seth, that is a great question. Seth asked, what if it's the first of its kind? They can't look at the other robots that are similar. You are exactly right. And they can't. But most times, robots, there are so many different types of robots out there that even though they may have a different end purpose or problem to solve, there are probably robots that are very similar to it. So for example, maybe there are no robots that cut down trees, but there are robots that use tools. So maybe I would look at some different robots that use tools and compare it to them. So a couple of other questions that they answer while they're doing their research is energy. How is the robot powered? Well, I certainly wouldn't want this robot to be powered by plugging into an electrical outlet because there are no electrical outlets in the middle of the forest. I also would probably not want this robot to be solar powered because if I was in a dense forest, I may not have lots of sunlight reaching my robot. For this robot, the best solution would probably be a battery. However, could this robot have more than one energy source? Probably. Intelligence. How does this robot think? Okay, well, our robot's not thinking per se, but how does it do its tasks? Basically, this is the computer program. How is the computer program set up? Sensing. How will my robot know or figure out what's in the environment? So how is my robot going to know that I need the tree on the right cut down, not the tree on the left? It could be as simple as I'm going to have an operator picking the trees out. It could be that I'm going to somehow tag the trees with a remote sensor, so the robot only cuts trees with tags on it. Okay, and if my robot were put into a different environment with a different task, would it be able to figure out this new environment? Maybe. That's a tricky one for lots of robots. The next question we need to ask is, what part does appearance play in the function of our robot? Well, shape and form or design are important to a design's aesthetic qualities. It means what it looks like. Its ergonomics, its strength, its stability, its rigidity, and its safety. Things like surface texture, finish, and color can be appropriate to a design's aesthetic qualities. For example, some of the robots, like that harp seal that helps the patients with dementia, if it was a hard black circle, it would not be as inviting. So aesthetics do play a big role in that robot's design. However, my robot that's cutting things down in the forest, who cares if it's yellow or pink or orange? Aesthetics are not as important to my robot. So some robots this is going to be very important in, and others it is not important at all. We also need to think about what materials we are going to build our robot out of. The strength of the material, the hardness of the material, the toughness of the material, the density of the material, and the durability. For example, I have a picture of a gold bar up here and a picture of wood. Both of these materials have very different characteristics. Wood could catch on fire, but it's really cheap. Gold is really expensive, but it's not going to catch on fire. So material cost and availability are also important factors in robot design. Most robots are built out of many different types of materials. The next step is to create a prototype. You need to test the design and troubleshoot the design. That is true, Kyle. The weight of objects needs to be considered too, or the weight of materials. Great point. This is where you would do your drawing. Diagram it out. Then you are going to build your robot. And here's just two little totally different robot pictures that I put up here. You are then going to program and test your robot. You are going to evaluate the design of your robot. So let's say I try my machine, and I have it in the forest, and it keeps getting stuck. Well, I'm going to need to do something different. Maybe I need a different type of wheel. Maybe I need a different material. Maybe my material is too heavy. Some good questions to ask while you are evaluating your finished product are: how well does the design function? Does the design look good? Like I said, that matters sometimes and not others. Is the product safe to use? Did I plan my work adequately? Did I find the construction straightforward or difficult? Were the most suitable materials used? Did it cost more or less than I expected? And how could I have improved my design? Those are all questions that you should ask when you're done designing your robot. We are going to do an activity together right now. What I am looking for is I am looking for two, let me explain it first. I need two team leaders. The team leader needs to have a microphone. The team leader needs to be willing to talk. And the team leader needs to be willing to keep their team on task. Okay, who are my volunteers? If I have more than two, I am just going to put them in a hat. All right. Okay, so Dane, Dylan, Kyle, and Lindsay, you guys would like to, and Clinton. All right, ready? Whoever guesses my number, the closest two are going to get to be the team leaders. I'm going to send everyone a poll. If you don't want to be a team leader, you do not have to answer it. Oh, I'm going to send it out. Don't worry. Okay, whoever is closest, go ahead and answer. I have my number written down. If you do not want to be in a team leader, do not guess. All right, I need 4 of you to guess again. I need Lindsay, Kyle, Dylan, and Dane. You 4 need to guess again. My numbers were 4 and 3, and those were the numbers that you guys picked. Okay, so let's go again. Just those 4. Pick a number. Okay, Dylan, I need your number. And who else? All right, Lindsay, my numbers were 7 and 3. So Lindsay, you are one of them. The 3 of you, we're going to go one more time. I'm only picking one number this time. My number was 6. So my 2 leaders are Kyle and Lindsay. I'm going to make 2 different groups. Each group is going to have 1 team leader. Everyone in the group needs to participate. Some of you do not have microphones. If you do not have a microphone, you need to participate through the text chat to your group. Now this is what you are doing. I am putting it up on the PowerPoint screen. It says, design a robot. Problem 1. A local pet shop. You guys are designing a robot. You are going to go through the steps 1 through 7 on here. I'm giving you 2 problems. You need to pick one of these 2 problems as a team. Problem 1 is a local pet shop wishes to sell a range of devices which automatically feed small cage pets when their owners are away for the weekend. Design and build a prototype device which would satisfy this need. Obviously, you guys are not designing anything right now, but I want you to talk all of this out. Problem 2. A community wants to construct a robot zoo in which the animals move their heads, open their mouths, and make appropriate sounds when they sense someone is coming towards them. Design and build a prototype that could satisfy this need. We're going to do this step by step. I am going to give you guys, I'm going to give you 10 minutes to do steps 1 and 2. If you have a question in your group, make sure you raise your hand. I am going to be popping between the 2 groups to listen to your conversations. Does anyone have any questions before we get started as a group? I'm going to make the groups right now. Does anyone have any questions? All right, you are doing steps 1 and 2.